What's going on, guys? Let's try these problems right here. The first question is asking a cone of height 16.2 centimeter and base diameter 15.79 centimeter is resting on a tabletop on its base. A uniform electric field of magnitude 4046 Newton per Coulomb points vertically upward. How much electric flux passes through the sloping side surface area of the cone? Now here the main thing to know is that the total flux through closed body is going to be 0, right? Total flux through closed body is equal to 0, right? And total flux is going to be equivalent to the flux through the base, flux through the base minus flux through the sloping surface. Through the sloping surface, and that is equal to 0, right? We found our total flux is 0, so this minus this is equal to 0. Therefore this two should be equal. So let's say flux through the base, so let's call this one, this B, flux B should be equal to flux sloping surface. Okay, now if we find one of them, we can find the other. So here the question is asking to find out flux through the sloping side of the surface area. Now if I can find the base, that's going to be equal to sloping side, right? Now to find the base, we know the base of the cone is going to be a circle, right? Circle, and the area of the circle is pi r square. So we can find the flux using this equation, pi r square times E. Okay, this is going to give us the flux. Now phi times the radius of this one is, base diameter is given 15.79 centimeter, so 15.79 divided by 2 times, since this is centimeter, we have to multiply this one by 10 to the power minus 2 to convert this one into meter, and then square, and we have the electric field that's provided, that's 4046, and if you calculate this one, you should get 79.23 Newton meter square per Coulomb. Now this is for the base. Now the question is asking to find out for the sloping side surface area, and if we getting this one base, this one, then this is going to be equal to sloping surface, right? So that's also going to be same value, and that is the answer for the first question. Now let's look at the second question. A huge, essentially infinite horizontal non-conducting sheet 10.2 cm thick has charge uniformly spread over the both faces. The upper face carries 27 nanocoulomb per meter square, while the lower face carries -94 nanocoulombs per meter square. What is the magnitude of the electric field at a point within the sheet 3.3 centimeter below the upper surface? Okay, let's go ahead and draw the diagram for this one. Okay, in the upper surface we have this charge, that is a positive charge. Okay, and in the lower surface we have a negative charge, and we know that for a positive charge the electric field goes away from it, so let's call this one E plus, and for a negative charge the electric field go towards it, so that's going to be E minus, and in the outside it's also going to go like this, and for this one is going to go like this, right? Now the question is asking to find out the electric field at 3.3 centimeter from the above surface, from here. Now let's look at the equation. Now since we are trying to find magnitude at a certain location, ER, that's going to be equivalent to magnitude of E plus E plus electric field of the positive charge plus electric field of the negative charge, and electric field of these charges can be calculated by using this formula, Q plus over 2 epsilon naught and plus Q minus over 2 epsilon naught, and let's plug the values. So let's separate this one so we don't get confused. Okay, so here we have this one. Also we can just go, now let's go ahead and plug the values. We have the Q values, that is we have 94 nanocoulomb per meter square and 27 nanocoulombs per meter square, so this is going to be just 94 plus 27. Since we are looking at magnitude, neglect the negative sign, right? So 94 plus 27 times 10 to the power minus 9, because it's nano coulombs per meter square, over 2 times epsilon naught. Epsilon naught is this value, 8.85 times 10 to the power minus 2, actually 12 coulomb square per Newton meter square, and if you calculate this value you should get 6836.16 Newton per coulomb, and that's going to be the final answer. I hope this helps. Thanks for watching.